I want to welcome you all to Elijah's Corner, okay? No. Hey everyone, well not everyone, but hi Starks, right? For my final project, something that I love to do is make videos, okay? And so for my final project, I decided to make a video in the format of something that I like to call Elijah's Corner. I did this for journalism, doing another project for journalism as well with that same title. So I wanted to continue that theme. So right today for my project is going to be Elijah's Corner Chemistry Edition, okay? And so for my project, right, we had the option to do many things, right? We had the option to do chemistry in clothing, chemistry in sports, chemistry in art. I just was thinking of which topic to do. I really wasn't sure. All of them caught my attention, of course, but I just really wasn't sure which one to do, okay? But, right, and there's a new term on TikTok, which is called being a big back, right? And as me being a big back that I am, I decided why not do chemistry in food, okay? Chemistry in food. And beyond that, I think food is something that especially as young people, we all connect on, right? And so I wanted to really focus in on chemistry in food. So with that being said, okay, food and chemistry have a lot to do with one another. Okay, it may not look like it, it may not sound like it. I believe that a lot of people underestimate how much food and chemistry are intertwined, how much chemistry goes into making food. And it's not necessarily always exact chemistry, but sometimes the techniques that are done in chemistry are the same ones that are used in food. Okay, a lot goes into making delicious food, right? Science, specifically chemistry and food intertwine, right? And so obviously we were asked to connect three things that we learned in class with this topic, right? And so the first thing that I immediately thought of connecting was the scientific method with food. The scientific method is in order: question, research, hypothesis, experiment, data analysis, conclusion, and communication. Okay, and so that is the 7 steps to the scientific method. I'll repeat it once again: question, research, hypothesis, experiment, data analysis, conclusion, and communication. And so you may say, well, what does this have to do with food, right? What this has to do with food is basically, this is a process of developing a conclusion, an answer to something, right? And it is an example that I thought of was, for example, when people try new food combinations, when someone is making a new food mixture, they think about whether this would mix. They question themselves whether this would mix, right? And it's as simple as me wondering if chips would taste good in a sandwich, right? It's as simple as me wondering, okay, if I don't know if you've ever heard, right? But I'm gonna put it on the screen, right? There's something called, a chamoy pickle, which I'm gonna show you what a chamoy pickle is, and you'll see this chamoy pickle. Okay, a chamoy pickle is a pickle. Typically they wrap it around with a fruit roll up and Takis. They dig out the inside, they put Takis. And I'm gonna be honest with y'all, I don't like that. Okay, I don't like anything pickly. I don't like anything that is pickled. Things to me should not be pickled. You know, people can say whatever they want to say, but just because I like food does not mean I like all food, okay? But, right, it's the same thing as me wondering if those things taste good, right? First process, I question, would this taste good, right? And then you go on, for example, right, if we're talking about research, and I bring this to a Gen Z version, which is we go then on the internet, we go on Instagram, we go on TikTok and search for this food, search whether people like it or not. We do basically, in other words, research of what it is that we think we might like. There's a hypothesis, meaning, for example, if I see that chamoy pickle, me personally, I know I don't like pickles. I've never tried that, but I know I don't like pickles. So me, when I see that, my hypothesis would be, if I was going to try it, I do not think I'm going to like this. But now I'm going to research it to see how they make it, where you can get products from, things of that nature. Then you do your experiment, which is trying the food, which is making the food, which is science, right? Typically, people do an experiment to figure out whether their hypothesis was factual or not. And then we go to data, right? And we say, well, how do you find data in that? I'll show you. Data is the review of how I like the food. Data can be on a scale of 1 to 10, how much I like the food, and then you make a graph, right? It can be as simple as me and I have a couple friends or a couple family members try this food. That's a form of me collecting data to see who likes the food. But with that being said, then we come to the conclusion whether I liked it or not. All right, and then you communicate, meaning that then that is, for example, that's as simple as me calling a friend and say, listen, I tried a chamoy pickle today, I hated it, disgusting. I don't like it. Maybe you will, but I don't. Okay, it's as simple as that. Another way chemistry and food encounter one another is with concentrations and dilutions. Okay, concentrations and dilution. Concentration is the removal of a solvent which increases the concentration. So mind you, right, I know I use the same word at the end, but they're kind of in a different context. The word concentration is what we're talking about, but now where they're saying concentration, the definition of that is the removal of a solvent, okay, which increases the concentration of whatever it is that you're making. Okay, dilution is the addition of solvent. Okay, so concentration is the removal of solvent, dilution is the addition of solvent. Okay, and so now I've been using this word solvent this, solvent that. What is a solvent? Okay, right? You heard me throw around that word. What is a solvent? Okay, solvent is a molecule with the ability to dissolve other substances which are solutes to form a solution. Okay, so essentially, if we want to think about it like this, concentration is the act of focusing, right? Concentration is the act of focusing. So in a sense, when you concentrate, right, you're removing distractions because you're concentrating. Okay, so concentration is the removal of a solvent. Dilution is adding a solvent. So when I'm diluting, we could say, right, and less related to doing work, I'm adding distractions to my area, which then causes my work to not be concentrated and when it's supposed to be concentrated in, right? And so with that said, bringing concentration and dilution to us, right? Meaning, how does that apply to the food and drinks that we make and eat? Okay, now I'm gonna show you how. Okay, I'm gonna show you how right now. When you make Kool-Aid, all right, how many know what Kool-Aid is? All right, I'm gonna show you a picture of what Kool-Aid is if you don't know. And if you don't know what Kool-Aid is, no childhood, okay? Right, if we bring it to us, to how this applies to us, Kool-Aid, right? When you make Kool-Aid or some type of powdered drink, whether it's Tang or I don't know, some type of powdered drink, lemonade, iced tea, when you get those packets, you know when it's just so bright, right? Meaning that the color is so vibrant in the glass, and then you try it and the sugar level is on 1,000 million grams because it has so much of it, so the color is heightened, the flavor is heightened to an extent, the sugar is heightened, right? That is a heavily concentrated drink. That is a heavily concentrated drink. So if I drink a Kool-Aid that's mad red, that's mad bright, such as this one, okay,
Dave, this one has a little sweetness to it,
okay, then it's going to mean it's highly concentrated. Okay, and so let's think of it like this again. Concentration is to focus. So the drink is very focused in color and flavor. It's very exact. Have you ever tried a Kool-Aid? Okay, have you ever tried a Kool-Aid that just gave water aid? And I'm gonna explain what I mean by gave water aid. Instead of tasting like Kool-Aid and tasting like something that's, you know, like sweet, flavorful, whatever, it just really tastes like water with a dash of Kool-Aid. It tastes like they said put a little spice and they just put a little bit too, they just put like a little dash. Okay, whereas when you drink the other Kool-Aid, like I example, you're like, you kind of get like, and so then it's like with this one, it's just water, it's just bland, it's just not it. Okay, and so it's like even the color is not strong because there's not enough powder. That would be a diluted drink because the flavor is not strong, the color is not strong, so it's diluted, it's distracted, right? The point of the drink is to be Kool-Aid, and right now, let's say a highly diluted beverage would be one that is very light in color and not flavorful, right? Not flavorful. It just tastes like water. It tastes like water with a side of Kool-Aid powder. This is what we will call, like I said, a diluted drink, a not focused drink, right? Those who know. The third way I connect to something we've learned in class to chemistry and food is rates of reaction. All right. So now we're going to get a little bit more deep into this. Rates of reaction. Okay. That is the speed at which reactants are converted into products. According to the collision theory states, okay, that chemical reactions can only occur between particles when they collide. Okay. So the rate of reaction increases with the increase in the concentration of reactants. According to the collision theory, temperature also affects. Okay, it says a chemical reaction that takes place at a higher temperature generates more energy. For example, when let's say I have food and I'm storing food in a refrigerator, it's always best, that is on a cool temperature, right, to preserve the food, right? Because the rate of reaction will change depending on the temperature. For example, if I have it at basically, let's say a room temperature, okay, the food will spoil quicker. The speed in which the food is going to spoil will be quicker depending on the temperature, because as I stated, temperature is one of the things that affects the rate of reaction. For example, let's say if I'm cooking food and the temperature is very high, the food is going to get cooked faster because of the rate of reaction, right? Because the speed in which this thing is reacting and turning into a different product. Let's say if I'm cooking an egg and it's raw and the heat is on really high, okay, by the time, let's say, I would say, right, that an egg will most likely, and this is where experiments come in, right, because an egg, I would say, will be most likely faster cooked, okay, at a higher temperature. That is going to cook extremely faster, and the product is going to be produced faster. Now, if the temperature is low, it's going to slow down the speed in which my egg cooks, right, which then we could measure that in a graph. For example, putting the rate of reaction, meaning the speed of how things cook depending on the temperature, right? Because something in food is temperature is a big thing in food, right? So how many times have, for example, right, if a refrigerator does not have light, for example, and you leave food in there, that is going to cause the food to spoil because it's not at the temperature that it needs to be, meaning a cooler temperature, which then causes, let's say if there's milk in there and it's not at a cool temperature and it's in a heat, right? It's in a higher temperature, not in a cool temperature. Okay, a hotter temperature is going to cause the speed of you could say, the spoiling process to increase, to be much quicker. And so a chemical reaction that takes place at a higher temperature generates also more energy. So let's say you'll be generating more energy with, let's say, cooking an egg at a higher temperature than cooking an egg at a low temperature. Okay, and so this is just another way, the rates of reaction is another way in which food and chemistry mix. The reason why it's so important to know certain things about chemistry, because it's going to help you in everyday life. It's going to help you to understand why things are the way they are. One of the things that we did in class, which was amazing, which is where I also got the idea for the concentration and the dilution, was that we did a project, or a lab, I should say, tasting different types of lemonades and looking at the color of these lemonades to see which ones were more concentrated and which ones were more diluted. Okay, by taste and by color, you will see which one has more, you could say more powder, meaning more concentrated. Which one has less, you can tell. And you can tell by flavor. Like there was ones that just tasted almost basically like water with a dash of lemon. That was not concentrated. Okay, and so that's why I say chemistry and food have a lot to do with one another. And those are three ways that what I've learned in class shows me what food and chemistry have to do with each other. Okay, thank you for watching, thank you for listening, and I hope you guys have a great, amazing day. This was Elijah's Corner.
It felt like a prison. Forever was doing my time.